There we go. Hey, everybody. Welcome back to another one of these. It's AzureFunBytes. My name is Jay Gordon, and we're doing another one of these, and we're doing something a little different this week. Normally every week I create a video for you, and I give you a little bit of an introduction to something within Azure. And, I wanted to kind of switch things up this week. I really felt like, you've gotten some of the introduction to the tools that are on Azure, but what about the products that are out there that can kind of complement Azure? There are a lot of great vendors that do some really interesting stuff, and I think today what we're going to do is going to focus on one of those vendors who've got a really cool product that I think works great with Azure, and we'll focus on the integration with Azure Kubernetes Service. Because let's look, this week is KubeCon, and so it's an opportunity to look at some new features in Azure Kubernetes Service. Then Ryan will talk to us, my guest today, a little bit about how these two products work together. So before we get started and I introduce my guest, I want you to kind of take a look at this, okay?
If you're running an application at scale in public or private clouds, you have to tame almost boundless complexity. Thousands of hosts, tens of thousands of containers, multiple infrastructure platforms, all of them generating a steady stream of data about their health, work, and performance. Datadog brings together all this observability data with infrastructure metrics, traces, and logs in one integrated platform. You can collect data from hundreds of technologies for visualization, troubleshooting, machine learning, alerting, and more. Visualize your entire infrastructure for a bird's-eye view. Sort and filter your hosts using automatically generated tags, and dive in for a detailed view of any host or container. See how all your services interact, and automatically map your dependencies to find bottlenecks in your application. If you see something interesting on a dashboard, you can drill into related processes, hosts, or logs for more information. Your processed logs automatically capture details like error messages from your application. For more context, you can pivot to end-to-end traces to see how the user request was carried out, along with the full stack trace from the error. When you need to find the source of an issue, faceted search helps you quickly drill into all your traces and logs. Here, we're searching our traces for a specific customer, service, endpoint, and error code. Datadog automatically alerts you via email, Slack, PagerDuty, and other tools about any issue in your infrastructure or applications. So you'll find out immediately about any unexpected traffic spikes, elevated latency, or looming capacity limits. Using automated browser tests run from around the globe, you can even find out when your users are unable to complete critical actions like signing up for an account. And with machine learning features like Watchdog, Datadog automatically detects performance anomalies anywhere in your systems and surfaces correlated troubleshooting data so you can identify the root cause faster. In any stack, for any app, at any scale, anywhere, Datadog brings together metrics, traces, and logs so you can tame the complexity of the modern cloud age. Start a free trial today at datadog.com.
And that being said, I want to introduce my guest. From Datadog is Ryan McLean, all the way from the other side of the coast in North America. I'm here in New York City. You're in, where is it?
Vancouver, Canada, just above Seattle.
So. Yes. So thank you so much for joining me today. I'm really lucky to have played around with Datadog in the past. And I think it's really cool that it's a really awesome opportunity to get a huge view on your entire IT infrastructure. And in our case today, Azure.
Yep. Yeah, I think it's key to be able to see everything that's going on, right? Especially if you're on-prem, on the cloud, multiple Azure subscriptions, as I've seen before. It can be it can be a challenge.
And we talk so much about being able to see everything. If we monitor it, we know about it. And if we make sure we're paying attention to the important things, then we'll know whether or not our applications are performing the way we expect them to. And I think that tools that are built into Azure are great to do that. But if you need to go beyond Azure and you need to implement multiple, infrastructure sources, different clouds, your data center, whatever it is, I've come to learn that what you're able to provide is kind of a great way to view everything together.
Yeah, you got it. I won't give a big sales pitch here or anything like that. But before coming to Datadog, I did use Azure, I did use AKS, and I did use Datadog. So for me, I got a taste for what's possible, I guess. AKS itself, I got to hand it to you, is a really good service, right? It's a great way to get started with Kubernetes, and it's something that we used in prod. Specifically, we really like the way that it integrated with Azure DevOps to be able to help us deploy things on a regular basis as we modify things. What's nice about Datadog is you can do that same sort of stuff as you're deploying at the same time. So in Azure DevOps, you can actually have it check if a service is healthy in actual Datadog monitors prior to going down further into a pipeline, which is nice. And that's something we leverage quite a bit. So it's having seen it in production, it's something that was kind of magical at the time. We started with VMs and just the resource group integration. So being able to add Datadog as an extension to a resource group is how we got started, and then sort of went from there into AKS. But yeah, I don't want to say it's simple and easy. There's certainly considerations to think about, especially when you go from dev to staging to prod. Things might be a little bit different than you expect. But it was actually really handy to be able to see what was going on when we had issues, bad code deploys, that kind of stuff. It's definitely really handy.
So that eventually led you to going over to Datadog. How long you been there now?
Not very long. So if I mess up at all, I've only been here 6 months. I'm learning a lot. We also just had a massive conference where we released quite a few different products as well.
Dash is called, right?
Yeah, you got it, DashCon. So it finished last week. We had a few workshops and stuff like that just finished yesterday, but there was a lot of announcements, a lot of new products, a lot of modifications to other products, and some changes as well in the Kubernetes monitoring, which I'll talk about when we get there. Sure. But things are changing in the Kubernetes ecosystem really quickly, and for us, it's important to stay with it, right?
119 this week, and a lot of big changes. Some stuff that happened over with Azure specifically is the add to ephemeral disks. That's going to be part of AKS, which I think is really useful, especially if you're doing some data stuff and you need to have things hosted in a certain place. And so we've got ephemeral, and then a more storage integration, which I think is really cool. Being able to use Azure Disk for persistent storage, and those are really, really performant, have a great SLA, so you're insured. And then also integration with Azure Files, which is a great way to actually use an active NFS, if you will, or Samba share. So tons and tons of files. So I thought that was really interesting. And one of the things that I really liked that I think will show once we deploy a Kubernetes cluster in this is some of those new features in AKS. And we spent some time yesterday, and I showed you some of those new features around being able to view your deployments live from a not even needing to use the Kubernetes what is it called? The control panel, but actually within Azure. So I think that's going to be really interesting. There are, like I said, there's tons of monitoring options built into Azure that you can actually export the data directly to Datadog. And so I think that's why we're talking about complementary products today. We're talking about things that work together really well. And I think that's why we're kind of doing a combo. We're doing this together, and we're going to make this work. So you ready to kind of walk through some stuff today, Ryan?
I can't wait. Let's get started.
So the thing I think we can get started with is just talking about the fact that this week was KubeCon. There's lots of really interesting new ways to use Kubernetes. But what we want to show you today is, one, how to get a Azure Kubernetes cluster on using AKS up and running. And then we want to talk about how to deploy an application that our friends at Datadog have put online, which has got some microservices that will easily deploy within AKS. And then once we finish that, Ryan's going to kind of take over and show us about the Datadog side of things and how we can actually slurp some of this data, get some information, and eventually have a better team. Our team will know what's going on. And so I think what we're going to start with, Ryan, is I'm going to share my screen.
Right on.
I'm going to bring this up. And so what we're going to be working with, and I've got a branch right now, and the only reason I've got a branch that I'm going to share with everybody is that I feel like I made a specific branches because I just wanted to add one little change. I'm waiting for it to get merged in. And so if you want to follow along with what we're kind of doing today, I've got this branch up and running. You can basically just kind of clone it. And most of what we do today, you should be able to do if you have an Azure account. If you need a free account, right underneath, there's a crawl beneath me right here. You see it? I think it's underneath you. Yeah. And so if you keep going like this, so you'll see there's a crawl there, and there's two links. So there's obviously a link to $200 of free credit with Azure, and then also the Datadog URL, and you can go there and get even more information. It's just as simple as Datadog HQ, just like you would go to Azure.com. Hey, who knew internet?
We're happy to give you 2 weeks free as well.
Sure. So what we're going to do is take a look at this. Oh, did my merge get? I want to see. Let's see.
Maybe.
This is equal. Let's see.
They're pretty quick.
So I made a change to the Kubernetes manifest.
Oh, not yet. Yeah, it doesn't look like it did yet.
Yeah, not yet. Anyway, I just wanted to make a small change to Kubernetes manifest, and that's why I built my own branch today. We'll explain why I made that change when we kind of go along. But anyway, the application that we're going to be playing with today is called E-commerce Workshop, and it's a really great distributed application. Ryan, you want to give me just a few bits and pieces on what it's built on?
Yeah, no problem. So basically, this is a distributed app written to essentially let us run workshops on Kubernetes. So it's called Store Dog because, of course, and most of what it sells is like dog accessories, dog gear, that kind of stuff. And what it allows us to do is actually sort of show, you can see that there's an issue actually in the app that we can talk about, but it allows you to show sort of like a front end, a back end, that kind of stuff. So it's primarily on Rails. It's got a Postgres database, I believe, the last I checked. And basically, it allows us to show you, it's kind of like a fork of Spree, basically. So an e-commerce workshop that we've made our own, and we've added a few things in, like an advertising service, that kind of stuff, just to sort of show things that can break, the composability of an app, how the microservices might work within Kubernetes, how they call each other, that kind of stuff.
And we'll look at some of those microservices as we kind of go along. But this is just the basic, what the application looks like on the front end. On the back end, when we get into the cluster, I'll give you all a further look into it. So the first problem we're going to solve is we have this store and we want to put it online somewhere. And so what we're going to do is we're going to put it on Kubernetes. That's what we've decided. We as an organization at the StoreDog company, we've looked at how our application was originally built, and we thought, you know what, we've got it on all these servers. And so the team got together, and what did they do? They said, we're doing Kubernetes, Kubernetes, Kubernetes. So they tried it on their own. And then they decided, you know what, let's move our microserviced application from our own distributed Kubernetes with VMs that we did on our own to let's use Azure Kubernetes Service. So that's just kind of an idea of what the problems. So the first problem is, let's go ahead and take all this, the code and the Kubernetes aspects of it, and let's get them into a cluster. All right, Ryan?
Sounds good to me. Let's do it.
Cool. So I've already built a Kubernetes cluster only because it takes about 12 to 10 minutes, maybe a little less depending on it, because let's talk a little bit about what's under the hood. While you see this, and this is what a Kubernetes cluster looks like in AKS. What you don't see right here, and we'll go back a bit to resource groups. So right here, in the left rail, we can always go to resource groups. And if we go here, there's another resource group that's been created. So FunBytes is where our Kubernetes cluster lives. But if you go into this MC FunBytes, and you'll see it's got the same kind of information, we'll see that there's all the VMs, a node pool, a load balancer, all the things that kind of make up an Azure Kubernetes Service cluster. And really all it is, it's some virtual machines. So we'll go here to a virtual machine scale set. We'll take a look underneath the hood in instances, and we'll see it's just 3 virtual machines. And so what Azure does is throws a reasonably simple to use, I don't want to say simple to use, it provides you with a control plane that makes sense for users. And you can interface with that control plane via the portal, via PowerShell, via CLI. You can use different REST APIs. The fact is that you can work with all the things that are here from just a simple resource, and I shouldn't say simple, from a control plane that makes it
simple for you.
from a control plane that makes it easier for you to build and work with your Kubernetes cluster. So there's kind of a few ways that you can build it, and I know, Ryan, I provided you with a script, and so I'm going to go ahead and share that script with everybody. If you go to my GitHub, and there is a script here that I created. Let's just go to repos. So what I did was I basically wrote a little bash script that acts as an all-in-one creation, and it will do basically create a Kubernetes cluster. It'll create a container registry service. Now, we don't necessarily need that for what we're going to do today, but if we wanted to build custom containers, it's useful. So I'm going to share that in the chat right now. And what this will do, if you want to, is allow you to just add some variables. So let's take a look at it really quickly and show you what you would do. So we can run it right here in the Azure Cloud Shell. And I'll show you one that I've already kind of populated. So we're going to give this a second while we do that. But I'm going to show you that we could just go to Add, go here to Kubernetes Service. And we could just fill out things here, like next, last. So I can create a cluster, and we'll call it J Ryan. because we're here and we're hanging out, right?
We're pairing, right?
Yeah, sure. So I'm going to give you West US 2 because I feel like that's closer to you than it is
There
to
you
me.
go.
It's probably in that area nearby. And we're going to use 117.9, which is the most up-to-date, not preview version. If we wanted to do stuff in preview, we've got those options. We don't necessarily need to. And so what I'll do is I'm going to start it off with 3 nodes. That means 3 virtual machines are going to be underneath the hood to create our cluster. And now what if we wanted to, we could actually create multiple node pools, and node pools will allow us to mix operating systems, or even we could modify the actual virtual machine type. So let's say I wanted to run something, I don't know, with ARM. I don't want to run standard. I could build a separate node pool that'll be part of the Kubernetes cluster.
I
So
didn't
we can use
much ARM. That's really cool.
Excuse me a second, and it'll tickle in my throat.
No worries. Yeah, one of the things I really liked about this method is it spits out like an ARM template that you can then use as part of your pipeline in Azure DevOps. So it's kind of like the best of both worlds, right? And you get the Cloud Shell right there as well if you want to actually run a script.
Yep. So we'll go ahead and we'll just click some of the defaults. We won't use virtual nodes. We're just going to use the defaults right now. Authentication, it'll create a service principal, and that service principal will allow you to use role-based authentications to create a trust between your Kubernetes cluster and other services. And so the most common is AKS to ACR, Azure Container Registry, so that you can do pulls on your container. And I think that makes it really simple that we go ahead and we, out of the box, just kind of say, as you set everything up, here it is. So we take care of that. We see we have some options for node pool encryption, so the disks are encrypted at rest. We can set our DNS. We can create a load balancer. We can make this a private cluster if we don't want to do public make it publicly accessible. We've got different network policies for ingress and egress, and if you want to use Calico, for those of you who know what it is, you can use Calico network policies. If you want to find out more information about the different types of network policies in Kubernetes, go check the docs. Application routing allows it easy to access applications to deploy to your cluster, creating accessible DNS names. We're just going to leave that as no today. We can add integrations with other products, and we can use log analytics built into Azure to get container monitoring. And finally, tags if we want to add metadata, and then we click review and create. So Ryan, like you said, there is the validation that happens, and then Azure Resource Manager, which is our control plane for everything Azure that we build and create, delete, you name it. In this case, we're going to be able to see that it validates, and actually we're allowed to run this where we click create. And then Ryan, like you said, we've got this template that we can eventually save.
Yeah.
So we can download that, and if we actually take a look, it's just a zip file with the parameters and the template that we can even bring into VS Code and eventually make changes to iterate off of our cluster, integrate it into our full development pipeline, so that when we build an application, we can build a new cluster, all the infrastructure required around it. Maybe we need some databases and a database service. Who knows? But the point is that we can codify everything and not necessarily worry about every single time configuring everything manually.
You got it.
That's ultimately the big hope. So I'm not going to create this one, but what I am going to do is show you that there's a way to do it also using just a script. And so I'm going to kind of let this script run in the background today while we do this stuff. So I'm just going to open up another tab. And what's great about Cloud Shell is it's super extensible. Ryan, I know you are going to show us some really cool things that you do with it. I haven't really customized my Cloud Shell that much, but anyway, I'm going to show you the script. And if we go, I just cloned it into my Cloud Shell so that I don't have to worry about authentication things. And if you look at the script, it's very simple. We've got a couple of variables that we just want to fill in, and it's in Bash. I just wrote this because it's quick, dirty, and it's not meant for more than just we're doing a demo today. And so we basically can state the group name, the location, which is the region we're going to build this in, the name of the cluster that we want to create, and then the ACR, the Azure Container Registry, where we can store images. We can create all these things. And what's really great is we've got this little Kate's version or Kubernetes version where what version of Kubernetes we can run. And so Azure actually has a command to show you all the versions in the region we're in. So I'm just going to go ahead and set this variable manually. In my case, I'm going to do this as location equals, and we're going to say East US, which is the East US area of region of Azure. And then what we can do is run this command right here, which I just have commented it. So we'll just copy this, paste it in here. And what's going to happen is Azure Resource Manager is going to tell us the versions that are available. So it's kind of like that drop-down list we saw before. And all I can do is just say that this is the version I want to create. So I can just state I want to create a resource group, and we're just going to call it Jay and Ryan, because we're here and we're having a good time. We'll state like East US. We'll just come up with a AKS name. So this is the name of the server, Jay and Ryan. And then an ACR name, the Azure Kubernetes, I should say an Azure Container Registry, where we can actually keep our container images if we want to. And we'll just call that Jay and Ryan ACR. And then finally, right here, we'll put in the Kubernetes version that we were talking about. Copy, paste that in. So I used my preferred VI. If you wanted to, you could have used the minimal version of code, VS Code, and you could have just done this. And it'll give you a more graphical version that maybe if you're using something like VS Code at home or on your local computer, you can use this. So we just close the editor. And so what I'm going to just do is type bash AKS ACR. And so right now it's going to do, it's going to read off me. All right, let's just go back here. That was peculiar. Sorry about that. So let's just type bash AKS ACR. And so what's going to happen right now, and it's pretty cool, those parameters that we provided in the variable section are going to be sent to Azure, and it's going to be similar to kind of what we did in that ARM template. So, you know, in the ARM template, we filled out everything, and we just said, you know what, do this all at once. But right now, I've got another. I think I've got some. Anyway, I just wanted to show you. I think I have too many clusters running at the same time.
Your limit.
Yeah. But anyway, it's a demo. When you do it live. Anyhow, by the time the script finishes running, you'll be able to then run a command to get your Kubernetes credentials. And it's really simple. So the name of my cluster that I've created, and we can run this either here locally, or we can run this in my Cloud Shell. So I'm just going to pop this here, the Cloud Shell. Let's clear this up. Not clear. Just going to pop this command, and what this will do is AZAKS get credentials. So it'll get the credentials of a Kubernetes cluster that we've created. And so we've created in the resource group FunBytes, and the name of the cluster is JAKS JDemo. Or I should say JAKS demo.
And this seems simple, but honestly, when I saw this, there was like a light bulb moment, because you're in Cloud Shell, but you're already authenticated, so you can retrieve the Kubernetes credentials without. I know you had a bit of a re-authentication there, which is actually a good thing. You should make sure that the session's up to date, but the fact that you can just pull it down is actually awesome.
So we got a question. We're going to include some Azure SQL database. Not today. We've got some databases that are already created by the manifest, and we'll show you that when we get to the manifest. So now we've got our ability to kind of take a look at our cluster that's been created once it's finished being created within Azure. So if we use AKS commands, or I should say AKS commands, we can manipulate everything if we want to about the actual control plane aspect and the underlying VMs. So if we wanted to update the amount of VMs, we could do that through this command line. But if we actually want to work with Kubernetes, we're going to need to use, which is the basis of all this Kubernetes, is kubectl. And so what we're going to do is just give you the most simple way of showing you some commands. And the first thing we're going to do is show you kubectl get nodes. So our VMs are nodes. We've talked about this a few weeks back when I had Eric St. Martin on. These are just the 3 virtual machines that Kubernetes is capable of deploying pods to. Pods are the individual portions of your application that are eventually spread out. Pods are eventually built from putting together manifests. So if we go back here to the e-commerce workshop, when we go to Kubernetes manifests, we're going to see a few different manifests, and Ryan will talk a little bit more about these two as we kind of get through the cluster agent, the Datadog agent. But to actually get our application installed, we're going to go to this e-commerce workshop, and we're going to see there's 4 different manifests. So Ryan, I want you to tell me about what these 4 different services are as I click through them. But first, let's start with the advertisements, YAML.
Yeah, no worries. So imagine you've got a store that's set up on the web, but you also want to get some recurring revenue as people visit the store. So maybe you want to have like an upsell to a different company or something like that. So what this service does is when it loads the page, within that page, there's a microservice that can also be loaded to sort of show you advertisements. In this case, we're advertising our own site. So imagine it's like a call to action kind of page. But what this sort of shows us is that the advertisement service can basically be deployed to Kubernetes and can be updated independently of other services, which is something that's really nice about Kubernetes. The fact that you can actually have one team working on one service that's in like a different language than possibly the front end or the back end. So in this case, you can see how it's using Flask, right? So it's going to be a Python service, and the Python service allows that Python Flask team to actually work in this code base. And what I've seen in prod before and with microservices teams is that you'll end up with different groups of devs that are more familiar with different languages or prefer to do things a different way. Now, of course, there's standardization. You don't want to have too many languages, but at least having like a certain set that they're familiar with and feel comfortable with allows them to push things to prod without necessarily affecting the whole site. And that's, for me at least, that the joy of Kubernetes was being able to enable those teams to do that. So to sort of shift that responsibility left. So not to say, hey, everyone needs to write Go, we're going to do it this way, and it has to be this framework. But being able to allow developers to use the framework that they're familiar with in order to do rapid changes. So your time to delivery on a feature, for example, instead of having to like quickly do the merge game with other groups that are also trying to deliver features, it means that your commit and your deploy times can actually be faster. So your PR approvals, your merge requests, you're merging things in from other teams at the same time, or looping in changes that they've got. It's a little bit easier to do this way because you can actually push things in one direction while other teams are changing. On top of which, it opens up things like blue-green deployments, things like red-black if you're using like a different deployment engine, that kind of stuff. So you can actually do like multiple services in the cluster routed through DNS. So it actually opens up like a whole bunch of stuff once you start splitting these off into composable services. So that's kind of the advertisement service, but the same thing would apply to like the DB. So for example, if you've got like a DBA team or a team who is more data oriented than others, they may want to go in and update this Postgres server in a way that might affect downstream components, but in a way that everyone can approve and see, while at the same time not necessarily requiring like all of the services to be pushed at the same time. There's a question about Azure Database. I mean, you could use like Citus in Azure is actually a really good alternative. Or if you want to actually do this in dev, for example, like this, I kind of think this is more like a dev cluster. You could actually have it run in Kubernetes, but have the database service in Azure actually with Azure Database Service.
Very cool. So one of the things that you were talking about, like what if the DBA team was working, I think this is a really good kind of thing that we can look at here is the storage. So
Exactly.
If we're in a situation where the DBA team says, you know what, we're using Postgres for storage, that 5 gigs is just simply not enough for us anymore. How do we make a change and increase that? So without having to impact all these different things of the infrastructure. Right. We can only we only have to make this modification here and then redeploy it, and that redeployment will happen in a rolling structure based on how you've configured the way Kubernetes to deploy using the scheduler. These are really deep topics that we can look at in further episodes when we get a little bit deeper into these things. Today we're going to kind of look how each big service that comes along it essentially has its own manifest. And then there's the front end, and that essentially provides the front end, the website that we're going to connect. And this is the one thing that I made a slight change to.
Yeah.
In the this version, which is provided by Datadog, it provides just a target query that's internal. What I made some changes to is I made it that it provides a public IP address. And that public IP address, eventually you can connect to make some, get to the website, and that's as simple as that. And we'll take a look at that little change. I think it should be right here.
Yeah, I think maybe just in the branch, there was a front end.
Oh, you know what? I forgot to switch branches. Excuse me.
Yeah,
Thank
just
you
under your
for
code
reminding
there.
me.
No worries.
Let me just go over to this, and we'll go to my pull request. And so I just added, and that's the cool thing. It's an open source thing, and if you want to make a change, you can go ahead and submit it just like I did. And I just made a change to the manifest, and you'll see for the cluster IP service, I made it so it could serve on port 80, and then that service would be front-ended by a load balancer. And so we'll talk about what's next. So after we do all that, we want to apply these manifests so the services start running. And it's really easy to do that once we've cloned everything into our repository. So I've already cloned our repository into our shell. So I've already done that. In Cloud Shell, you can use your computer if you want to. I could just clone the Git repository here in my local shell. I could even just use VS Code, and I could clone the repo. So I'll just go over here. And the only reason why I'm showing you all the different methods is just it's useful to know how everything kind of works. Mm-hmm. So here, let me go here. I should be able to just clone this individual branch, shouldn't I?
You might want to clone the whole thing and then check out the branch, I think is how I normally do it.
You're right. But that's what I could do. I could just go ahead and clone this. We don't need to necessarily, but I just want to say these are all our different options. And then I could go into terminal here in VS Code, or I could do it in my terminal, whatever I want to do. But because we're already authenticated for kubectl or kubectl, however you want to pronounce it, I can just go into the manifest directory. I can go into the e-commerce app, and we can see all of our front end. So load balancer is an extraneous one I created, so I'm just going to delete that one. And so we're going to just apply these 4 manifests. And I've already done it before, but I'm just going to show you how it's done. So you just type kubectl, apply -f as the file, and then the file location. So advertisements. And so it'll go ahead and create the services and the deployment for it. If you want to know a little bit more about deployments and services, documentation, please. Then we're going to do the same thing with the database. So I'll just go ahead and replace this with DB. YAML, and it'll go ahead and create all the services that we need. After that, what we need to do is add the discount services. So we'll just type discounts. Created all those services, and now they'll start creating pods. We'll take a look at that. And then finally, we want to get our front end service and our load balancer up. So we'll just type front end as our next applied manifest, and it'll create everything. And now when we want to look at what's going on, we can type kubectl get pods, and that'll show us the services that are being created and the pods underneath that are being made. So these are all the little pods that are being created that have all these services running on them, and they've got a minimal amount of a Linux operating system. That minimal allows us to run the runtimes that are necessary to start Kubernetes, the containers within. So that's what we're working with here. And so what we can do when we want to get that pod is we could do a -w. We can actually watch it in real time and see what's going on. And we can see that the container for our front end is being created. And now if we actually want to find out about that load balancer IP, we can do the same thing with get services. And services are these other portions of our application that we run that allow us to have network connections to one another, so we can run a cluster IP service, or in our case, we're running a front-end external with a load balancer with a public IP. Kubernetes knows, it's smart enough to know how to go back to Azure and get this IP. Yeah. So we're going to run towards the end, and then you're going to kind of take over, Ryan. So if we kind of look, once that IP is created and we curl, it's not completely up yet, but once there it is. So now our app is up quick. And it's online. Yep. And if I want to go ahead, go to a browser, it'll bring it up. And so the great thing, it's probably one service that's just not fully up yet, because
sometimes this happens just as it's loading. Yeah.
Yep. So you can just see there's some internal network connections that are just because a service may not be fully up. And if we want to look at it, like I said, we could just get pods and see what's still running and creating. So one of these services, probably database, isn't fully up, but now it is.
There we go.
It refreshed and it finished. So Ryan, I showed everybody, the part where we created a Kubernetes cluster. And now, before we kind of finish that, I want to show everybody one more thing that I think is really cool, and then I want you to kind of take over.
Sounds good.
We talked about that new feature that I thought was really cool in Azure, and I want to just show everybody the fact that we can actually get a deeper view into what's been deployed. So let's just go to AzureFunBytes. We'll go to AKS demo, and they just created these new Kubernetes resources in a preview, and I think this is really cool. So we can look at namespaces, and it'll actually show the namespaces that you've created. If you want to know more about namespaces, check the documentation. We're using the default namespace, and we can see the YAML, that what's actually contained into it, inside of it, and I think that's really
cool. Yeah, that's awesome.
And we can also look at the workload, so what's actually running on the cluster individually, the amount of pods that are a part of it, and so here is our DB workload for those set of pods, discounts, front end, advertisements. These are just a way to kind of get a view, and then of course services and ingress. We can actually get our public IP address right here, so we don't have to even do a kubectl command. And so that's kind of like how we would get things working. But now, Ryan, I want you to show me, once we get them, show me a little bit how we would take a look at what's going on.
Yeah, no problem. So one of the things, I'm glad you touched on those new services, because one of the things I was scared of is that the dashboard's becoming deprecated, right? So it's something I used to use quite a bit. It even worked in Cloud Shell, which is awesome. It would like open up a port for you. But the fact that I think in 118, it was like deprecation notice. But in 119, I think it might actually be deprecated. Hey, ignore me running top here. I just didn't want to time out of Cloud Shell. But the fact that you can go in there and see those services now, and again, not to prop up the AKS service, but I think that's actually pretty awesome, because without the dashboard, it's a little bit hard, right, to see what's going on. So I've got a couple things up and running here. You can see that I've got just a code editor, sort of just talking through some of the steps that you would want to take in order to get Datadog deployed. So it's kind of a bit of an eye test here. Hopefully it's not too small, but what I'll talk about is just this is kind of the old-fashioned way. So just running all of the manifests. What I think is the way that I'd recommend right now is the Helm chart way of doing things. And the nice thing is, here, I'll just clear the screen here, but the nice thing is within Azure Cloud Shell, you've actually got this. I'll just maximize it here and make it a little bit bigger. You've actually got a way to run Helm already. So it's already installed, which is really, really handy. The fact that you don't need to authenticate, you don't need to install anything, but it's already there. So you can just run like a Helm init kind of thing just to get you ready to go. Oh, sorry, not Helm init. What is it? Helm install. I'll just clear this here. But basically what you do is you'd add your repo. And then after adding your repo, you would just, I don't want to say just, but you would add Datadog and then go from there. And the reason I'm talking about this is because there's 3 different ways of installing Datadog for Kubernetes. So right now, the one that I was showing was the daemon set, but there's also the Helm chart. And what's new in sort of in testing is the operator version. So what I tried to do, getting all fancy, was I decided to try doing the operator. It's kind of my first time doing it, so it didn't work out so well. So I started just sort of documenting the daemon set part as well. And I'll throw that in the repo after this stream and post it on Twitter. But what I probably recommend right now is the Helm, just because there's less steps. So if we go back to what's required kind of on the manifest side, it's not bad, but there are at least like 8 or 9 steps, right? So you've got to get if you're using RBAC in AKS, which I believe is the default now, you have to get your cluster role here. So again, these are publicly online. I'm just grabbing them from the steps, but you've also got your service account, and then you've got your cluster role binding. Now, it was new to me that I didn't realize it happened, is that there's actually, I think there's a little bit more security on Health Z or Health Z if you're in Canada on the AKS side. So it does require another cluster role binding, at least for us. And again, the Helm chart kind of takes care of most of this stuff for you, aside from this. So you'll need to know to do this. But basically, if you look through what it's doing, it's saying, hey, what we need to do is give you an RBAC role binding to allow us to authorize to Health Z, and then it tells you like what's actually going to talk to it. So it's basically allowing us to hit that endpoint to get stats about the cluster, which is really handy. And I'll show you the failure because I'm kind of a learn in public kind of person. But what happens is if you install this and you've missed like the RBAC part, what you'll get is you'll start getting stats about things running. So you can see that there's events, great. You can see that there's stuff going on. What you won't get though are these detailed stats. So you can see that there's some stuff missing. And I'll share a screen in a moment with all of it fixed because I'm trying to bake my cake at the same time as doing a demo. But the way you'd normally do it is by going through the Helm chart and actually just running through those steps. So what the Helm chart steps are, so you'd add the Helm chart repo. So this is helm.datadoghq.com, and then you add the Kubernetes stable. And then you do an update, so to make sure that you're pulling down the definitions, essentially, of the Helm chart. And then what you do is, in this case, there's a difference between Helm 2 and Helm 3. My understanding is that Azure is fully on Helm 3 now. I haven't come across any 1 or 2 lately, which is nice. So what you do is you grab this key, and I'll show you where it is in Datadog. So it's just here, under Integrations APIs. And the docs link you right to it, so there's a deep link in there. And you can see that I've got a few API keys. They're also masked, so I can show this screen on stream. But if I mouse over them, you might actually see my API keys. So you can see that this AZ stream or AZ stream is the one that I added in order to do it. And that what you would actually do, sorry, just to go back to the Helm stuff, is you would actually set the Datadog API key as a secret. And the reason I'm saying this is because it's really important for you not to expose API keys when, like, doing it the first time is great, but once you're into a pipeline, you might want to actually restrict access to API keys. And what's nice, again, I hate to bring up Azure DevOps all the time, but what's nice about the DevOps side is that you can put it into a secret variable, and you can actually have a matrix of responsibility to who can see that variable and who can't. So you can do things like cluster actions without necessarily exposing the API key. And on top of that, within Helm, you can actually add Helm as a step in there too. So doing this the first time manually totally makes sense. Like, get up and running, get it working. Jay's got a great script that we get you started. I'll share the script that I've got here as well. And then the next step is, like, how do we take those scripts and make this automated, right? So Helm's a great way of doing that. You can fork it, make your own charts if you want to do things a little bit different as defaults. And then they just talk about like different ways of getting Helm to do your event collection. I'm sure you saw that in the screen. I'll go back to it in a second, but basically a way to expose all those Kubernetes events, which are sort of like the lion's share of what you'll want to know about, like our pods failing, that kind of thing. So you can actually start hooking things up to those events. So if I've done a deployment and the deployment for my service is failing, maybe what I want to do is roll back that deployment, that kind of thing. And similarly, if I'm doing in the command line, I can query that to see what's going on. So you can see that I've got a Windows box up here as well. It's having some fun. Just quickly pop into Kubernetes. So all I'm doing is filtering these just so you can see the Kubernetes events. And I've got another cluster here that I kind of set up that's got some unhealthy events on it as well. So you can sort of see what's happening to like my ingress load balancer here. And there's 98 of them. So you know there's a problem. You can see this happening over and over and over, right? So it's something you want to look at. And I've set it to past hour, but you can look at past 7 days. Now, what I'd like to do is actually go from sort of my broken cluster to something a little bit more interesting, with more detail. So I'm just going to quickly log into a different cluster here, and I'll bring that over for you. Just 1 second. I think the main thing that's important is like that Kubernetes changes all the time. The docs change all the time. Ways of deploying things will evolve over time, and being able to sort of roll with those changes and update them is on us for sure. But also, as you go along, the way that you can set up AKS clusters quickly, test different versions. Like today we were talking about 117.9. We also talked about the launch of 119, right? The ability to test those quickly in Azure makes it so that you can see if your workload runs on the new version and sort of roll forward as well, which is great. So I'm going to drag this over. And this is sort of our demo account, but it'll give you a little bit more exciting than what I did with my trial account. I think this gives you still a little bit more detail. So what we have out of the box is like dashboards that help you with Kubernetes. So if I go to like the overview here, it will show you all of our clusters. And what we can do is in these clusters, we can actually drill down into different clusters and allow us to say, I know we were talking about tags earlier when we deployed, right? So when you tag things in, let's say, automatically for Datadog, we'll grab the region tag, the location for you, which is great. But we can also grab other tags that you might have. So if you want to sort, for example, by staging, by dev, by prod, you could do that using tags. And all of these up here are sort of just drop downs for tags. And I can zoom in a little bit here. But what I'm talking about specifically in this case is this cluster tag. So we can actually look at all the clusters we've got here. So if there's an AKS cluster, for example, we've got a demo AKS cluster. We can actually drill down into just that cluster by clicking it. And then if you want a dashboard that's just this cluster, what you can do is clone the dashboard and sort of hard code those variables for you. So these are a good way to get started. You can see that there's quite a bit of detail in here. Your pod's running my namespace, that kind of thing. This is the overall view of Kubernetes, and it kind of gives you a lot of info about what's running on it. If you're up against any limits, that kind of stuff. It can show you pod ready status, that kind of stuff. What's running, the events, everything filtered for the cluster that you want. But there's actually quite a few things that you might actually need to know about Kubernetes that are a little bit more detailed than you get in here. So if you want to just look at, oops, I lost it there. But if you want to look at deployments, for example, my mouse is being squirrely. So if you're more on the release engineering side or release management side, what you might want to know is, are the pods that I just deployed healthy? Are the things that I said should be running are running? So you can see here that there's, in this case, like the desired state of some of our pods isn't matching. So it might be something worth drilling down into to figure out why what I thought should run doesn't run. Now I've come across this before on scheduled jobs within Kubernetes. So I've got a job that will run, let's say every hour to do a cleanup. It's the Spark jobs or Airflow or what have you. Maybe it's talking to HG Insight, that kind of stuff. If I'm doing those heavy lifting jobs and I've run out of something like CPU and memory and it's failing, this trend will actually tell me what's going on. Now, what I typically see is people looking at these deployments and Azure DevOps at the same time. So if I just go into, oops, all right, it's super squirrely. Got to get that soft touch. But you can actually take pieces out of this Azure DevOps deployment section say just these events, for example, might be something that's interesting. You can correlate them with the Kubernetes side as well. And you can actually get at a glance what's actually going on. Now that's great to find problems, but just to take this a little bit further, sort of just to next level a little bit, if you need some of that deep content, what you can do is in Azure DevOps, you can look at these monitors, not on the Azure DevOps side, but on the Kubernetes side. So if I deployed a pod and it's not running, then maybe fail that pipeline. And I think that's really powerful. I think that allows you to like quickly, hit the big red button. So stop this deployment. Don't go further. Don't go from dev to staging to prod and auto promote. Maybe stop in dev and maybe let's reroute, figure out what's going on, that kind of thing. So it takes a little bit of the manual stuff that I used to do as a release manager out of the equation and allows you to deep dive in a little bit. It also allows you to give more of an overview of what's happening to more of your team. So for example, in my case, QA engineers were something that it's so much easier to communicate over a graph, over what's happening. So we talked a little bit about some of the Flask apps and things like that we have actually deployed. But if you've got your app instrumented with Datadog and you're running Datadog in your Kubernetes cluster, another nice benefit that you can get is actually sort of start pushing out the APM and the logs and the events to the agent to grab it. And if you can, just for a second, we'll talk quickly about one of these Kubernetes services. I think one of the powerful things that I've noticed in monitoring tools is that rapid feedback. So being able to do things like last 15 minutes is great, but if we actually go live here instead, we can actually do something like deploy a service, and you can see these are flying through. You can deploy a service and see right away what's going on in the service. And that's really, for me, that's really handy. Sorry, it's probably a little bit smaller. I can zoom in a bit here. But it is flying by, so you can see some of these are going through. Some of these are good, some of these are bad. I'm just going to see if I can click on one quickly and sort of go into what we would call like the ability to drill down, or what I would call it, the ability to drill down. But it kind of looks like a flame chart. Or if you use DevTools in Chrome, or let's say you're using the new Chromium Edge, you can actually drill right down into what's being called in this service deployed on Kubernetes. So in this case, it's that ad server that we were talking about, right? I was trying to click it as it was going by because there's so many events, but luckily I got the right one. What this allows me to do is actually talk about exactly what's happening here. So we can see right in here what's happening. So we can see that it's hitting the email service, it's sending an email. This is a bit more of like an expanded demo. Actually hit Mongo, that kind of stuff. It can go all the way through each call that it's got to every service, and it can tell you which one's taking the longest. And in this case, we can actually see that the GraphQL calls are taking a long time. So you can take that and drill down into what's going on. Now in this case, so what you might want to do is in this environment here, if you got many environments, you can pick different ones, right? So we just picked one at random, but we could also do things like you'll notice that some of these tags actually come up. So if we just wanted something that said, for Azure, for example, I believe this will work, Azure. Hopefully it's getting some traffic. If not, we can go in the past, but I'll just pick that out there. And there we go. But it doesn't look like it's as busy. Yeah, sorry. We're running up on time. I could talk about this forever.
Yeah. Since we're running up on it, I want to just ask our audience if anybody has any questions to make sure you let us know. And if not, the one thing that I really like about Datadog is that the integrations that you've got that can work into notifications and to making sure people can actually have a collaborative and almost conversational type of experience, I think is really cool. And if people want to demo it or anything, what should they do?
Yeah, so definitely hit me up on Twitter. It's just Ryan_McLean. I was a little bit late to the party. We've also got a public Slack if you want to hit us up there. So just chat.datadoghq. The other thing I would honestly suggest is setting up a trial account. So it's 14 days. If you're just getting started, certainly set things up. If you want to play with like a VM that's a throwaway or your dev environment, definitely do that. It allows you to explore without necessarily having to go through the sales pitch, the upfront, that kind of stuff, just to get started and sort of poke around. The other nice thing that we've got, and I kind of promoted or talked about it a little bit before, but we've also got workshops if you want to get in there and just learn the product. Definitely worth looking at.
Very cool. Well, I'm putting on the rolling down sounds, if you will.
All right, let's dance the sun out.
Yeah. So it's been really cool having you part of this today. I really appreciate it. People want to find you here online or anywhere else. I believe they can go to @Ryan McLean.
Yep, Ryan_McLean.
Very cool. And obviously, if you have questions about Datadog, if you have questions about Azure, get in touch with either of us. And I think we can go ahead and put you in touch with one another if someone has questions. But
For sure.
Just want to say this was really great. Thank you very much for giving me some of your time today. Anything you want to say before we kind of say goodbye?
No, I thought that was great. I think talking about AKS is phenomenal. It's a good way to get started with Kubernetes.
That's awesome. Hey, Ryan, thank you very much for being part of the show today. I really super appreciate it.
Right on. Have a good one.
Take care. Well, everybody, that's it for this week's Azure Fun Bites. I know it was a little different this week. We got a little bit deeper into things, and that's the whole process of learning together. Every week we kind of take a look at what builds Azure, what you build with Azure, and then essentially what people can use alongside with Azure. And so, as always, I want to say thank you to my guest, and this week it was Ryan McLean. He was kind enough to kind of walk through the creation of Azure Kubernetes Service, and then give us a little bit of insight about how he can start showing you, or I should say, how you can start using Datadog to kind of get you more insights on what's going on with your cluster. So once again, it was great to talk to you. I'm going to start moving into a new apartment, which means I may be taking a small break from a couple of streams. I'll make sure you all know when that's going to be, and maybe we'll reschedule until some different times. Hopefully we'll get some more guests and continue learning about Azure together. So this is Jay, and next time I think what we'll do is get into it again. So thanks for watching, and I'll see you next time.